Yiming. I'm an Elixir developer based in Shanghai. Today, I'm gonna share a library with you, Promox. As you can tell from its name, Promox is a library for defining mocks in our test. If you are already familiar with mocks, which is another popular library in Elixir to defining mocks, then you would find Promox public API to be very similar. So the usage of Promox is very simple, and its implementation is also very simple as well. So today's talk is not about how to use Promox or how to implement a library like Promox, but today's talk is about why would you choose Promox at the first place? Why would you use Promox basically? So we would touch on these three concepts here in the next 30 minutes: roles, protocols, and the mocks. So to answer our question of why would you use Promox, we need to answer this question first. When would you define your own protocols? Because if you are not using protocol at all, then it doesn't make sense to mock protocol functions, right? So I guess for most of us, the answer to this question is that when we have a bunch of data structures and have a bunch of structs already, then we would define our own protocols to have some polymorphic behavior for these data structures. But in this kind of scenario, then it might not make sense to use Promox or mocking uh, protocol functions. But what if we define our protocols first, then define our implementations? So that's basically today's talk. So in today's talk, I would introduce a kind of design that's called role-based design, and we would see how to design based on roles to make our code more flexible, and how to in Elixir use protocol to define these roles, and how to use structs to implement these roles later. And then finally, we would see how to use Promox to test these interactions between roles. Before we dive into today's talk, I want to thank these people for their inspirations and helps. I want to thank this great book, Growing Object-Oriented Software Guided by Tests, and Mock Roles, Not Objects, this great paper. This talk and the Promox library are both inspired by these two great resources, and they are highly recommended. And I also want to thank Queen Wilton for her great talk, Flexible Software Composition Using Protocols. And you would find the idea very similar. And I also highly recommend you to watch this talk. Finally, I want to thank my company Tubi because Promox is a library extracted from a project I built at Tubi, and without the support from my team, I wouldn't be able to try this new idea and contribute it back to open source. Of course, Tubi is now hiring in both the US and in China. So if you want to solve large-scale problems with Elixir, feel free to reach out to me later and join us. Yeah. Now let's dive into today's talk. So the first question is, what is role-based design? And what is a role, basically? So to me, a role is a responsibility plus a bunch of interfaces. So the responsibility is a job to do. It's what mission we need this role to accomplish. And the interfaces are the messages we can send to this role, and what messages this role can send out to other roles. Basically, the interfaces is how this role communicate with other roles in our code or in this world, basically. Now, maybe this idea is still a little bit too abstract. Let's see some examples. First, I think this kind of role-based design is very common in our daily lives. Let's consider PC here. I guess you are all watching this talk through a computer. So in front of you is, I guess it's a display, and for each computer we have a keyboard, a motherboard, and on the motherboard we have CPU, memory, and the disks. So each of these hardware components take a role in our computer, and for the display, its job is to display all these pixels so we can see them, and the interfaces it talk to the computer is maybe the display port or the USB-C port. By splitting our computer into components like this, and each component take a unique role in this system, we make our computer very maintainable. Because if we want to have a better display, we can just plug in a 4K display here. If we want to have a better CPU or more memory, we can just throw more hardware to the motherboard. If our display is having, if our disk is having some troubles, we can replace the disk with a new one. This is basically an example from our real life. So I also think that the role-based design should be very familiar to our Elixir and Erlang developers, because Beam processes also have roles. Here, let me use Auburn as an example here, because Auburn is my favorite library to process background jobs in Elixir. And to accomplish this job, to achieve this goal, Auburn has this supervision tree here. And whenever we start an Auburn supervision tree, it would start a notifier process, a midwife, and for each queue, it would start a queue supervisor. And it also starts a bunch of processes for every plugins we use. And under each queue supervisor, it would start a foreman, a producer, and a watchman. So all these processes have its own role in this kind of Beam virtual machine, and they focus on their own job, focus on their own responsibility here. And all these processes, at the same time, they talk to each other via their interfaces by sending each other messages. So they can collaborate together to achieve the same goal, which is to process the background jobs. So basically, without these isolated processes and their collaborations, Open wouldn't be able to do its job so well. I think by splitting our runtime system into roles like this, like notifier, midwife, and so on, we make our runtime system very resilient, because whenever a process dies, we can just start a new process that takes the same role. For example, if the producer dies, we can start a new process that takes the same producer role. And because it's taking the same role, which means it's doing the same job of the producer, and it also can receive the same messages the producer can receive and send out messages the producer did. So the system can work as before because it has a new component that plays the same role. Now, what if we can put this kind of role-based design into our code? And I think if we can do that, we can make our code more maintainable and more resilient. Now let's see how to do that in Elixir with protocol. Now let's face a real problem here. Let's imagine we need to move a bunch of large files from AWS S3 to Google Storage, and this job might seems simple at first glance, but if we have millions of files and each file can be gigabytes of large, then things are gonna be different because we need to make sure all these files are transferred correctly from S3 to Google Storage. So to do it well, we need to follow these 3 steps or even more. So first, we need to copy these files from S3 to Google Storage. Of course, we need to do that. And then after that, we need to compare the file hashes between old copies and the new copies to make sure the files are matching. And finally, we need to copy the database records. Let's check these files. So we have, because we have too many files, we need a database to manage them. So we have database records for the S3 files. And when we move these files to Google Storage, we need to copy these database records and update them so they can check files for the files on Google Storage. So how to implement this logic in Elixir? So with role-based design, we can define 2 roles with protocol. So one is called mover, and another is called comparator. And let's see how to implement, how to define them in Elixir. So first, mover is this kind of role that its job is to move the data from source to destination. So the data might be some kind of files, or it can some kind of objects, or it can also be some kind of database records. And the interface is very simple. It's just one function called move, and this move function can receive a mover struct and a source map and a destination map. So each mover knows how to find the data it needs to move based on this source map. Maybe this source map contains the S3 bucket and the path info, and the destination map contains the Google Storage bucket info and the Google Storage path info. So if the data move succeeds, this move function can return OK. Otherwise, it would return an error tuple containing the reason. And then we can have a comparator role here, and the comparator's job is to compare the data between source and the destination. So let's say we have different data on source and the destination. The comparator would find the difference and return a tuple saying that the data are different, and the reason why these data are different. And if they are the same, the comparator would return the item same. And with these 2 roles, we can define different implementations. We can have a file mover that moves the file from S3 to Google Storage, and we can have the DB mover that copies the database records from the older records to new records. And we can have a concat mover that takes 2 movers in sequence and calls them in sequence. And we can have a CompareAfterMover that takes a mover and a comparator, and also calls the mover first and call the comparator to compare the data that gets moved. So for the comparator role, we can implement it with different hash algorithms. For example, we can have an MD5 comparator here. So with all these implementations, we can solve our problems. But let's first see how to implement this CompareAfterMover first. So a CompareAfterMover is a struct that takes two fields. One is the underlying mover, which would do the actual data moving job. And another is the comparator it would use to compare the data afterwards. And it provides a new function that just return a constructed struct. Now let's implement the mover protocol for this CompareAfterMover struct. So when we call a move function on a CompareAfterMover, it would first delegate this mover.move function call to the underlying mover. And if the underlying mover does its job, it would call the comparator to compare the data between source and the destination. And only when the mover successfully moves the data and the comparator says that the data are the same, this CompareAfterMover return OK. Otherwise, if the comparator says that the data are different, it would return an error saying that the files are different now, and the reason is the reason returned from the comparator. So now you see an example of how to implement this mover role for CompareAfterMover. And we can do the same for our other implementations like file mover and the DB mover. So I'm not gonna show all these details here. And now we can compose. So let's suppose we have all these movers already, and now we can compose them together to solve our problem. So first we can build a new file mover and pass it to a CompareAfterMover with the MD5 comparator. And then we pass this CompareAfterMover to the concat mover with a DB mover. So basically, here is the body of our solution. And you would see that it basically matches what we planned before. So first we use the file mover to copy all the files we need to move. And then we use the CompareAfterMover to call the MD5 comparator to compare the file hashes between old file and the new file. And finally, we copy the database records with DB mover. So I think this solution is very elegant because it's basically translating our plan of our solution to Elixir code here. And we also have a natural layering of abstractions here. So at the top level, we have this concat mover. And this concat mover is composed from CompareAfterMover and the DB mover. And then the CompareAfterMover is composed of file mover and the MD5 comparator. So with this body of our solution, we can go fancy here. Like we can replace the DB mover, for example, with another, so we can connect to different database or something. And we can maybe replace the file mover with a cheaper or faster solution because moving these large files can take some time and take many network bandwidths. And then maybe we can replace the MD5 comparator with a different hash algorithm implementation. And the body can stay the same. We just plug in different components or different implementations here. So to move around our logic and to change our logic here. But since all these components play the similar roles, so they can work with each other well and can be composed in this body of our solutions. Now we've seen an example of how to use role-based design and how to implement role-based design in Elixir. Now, what if we want to test them, especially the CompareAfterMover and the CompareAfterMover? Now we should use some mocks. So now let's see how to mock these roles with Promox so we can test our CompareAfterMover. Before that, let's circle back to our real-world example here. So imagine we need to test a keyboard. I think the obvious solution is to connect this keyboard to a PC, right? But this solution might be a little too expensive because when you are building many of the keyboards, you might not have a PC or a PC is too complicated. You might build a dedicated simulator to test the keyboards you want to build. So this simulator can receive the signals sent from this keyboard and saying and testing that when we press a key, for example, A here, and the key code A can be sent from this keyboard, and our simulator can receive this key code and verifies that the logic is correct. So this simulator is the mock here in our real life. In our mock in our test plays the similar roles as well. So we can see how to test our CompareAfterMover with Promox. So now we need to test the case that the CompareAfterMover should return an error when the underlying mover succeeded but the comparator failed. So we build two mocks here. The first mock is for mocking the mover role. So the mover so we would expect the move function to be called with this mover, and then it would always return an OK item. And then we would build another mock for the comparator role. So we would expect that the compare function to be called on this comparator mock, and it would always return a tuple saying that the files are different even though we don't have any files to compare. And the reason why they are different is for test. Then we call the CompareAfterMover with these two collaborators. And then we can assert that the CompareAfterMover should return an error tuple. And the reason should be that the files are different and the reason is the same. Here it's for test. So by building mocks like this, we can test our combinators like CompareAfterMover very easily because we don't need to set up a complex scenario to make our comparator fail or to make our mover pass or to make our mover fail and so on and so on. We can just simply saying that hey, in this test, the mover is always going to succeed and the comparator is always going to fail. So, and then we can assert against the behavior of our CompareAfterMover. So now you see how to use Promox to test our CompareAfterMover. And but if you are an experienced developer, you may think that you've already been very familiar with role-based design, and the protocol is not the only way to implement the role-based design in Elixir. You may use behavior or even anonymous function to implement this kind of design and composing things together. So why chose protocol and Promox? So for me, I would choose protocol for its explicitness, because when you define a protocol with def protocol, we are defining a explicit role in our system if we are thinking in that way. And this might not be the case for anonymous function. We might not have a way to define roles explicitly. And when we use def implement to define implementations, we are also explicitly defining these implementations. And all these definitions are very searchable because we can just grab these keywords in our code base, and we would see how many roles we have and how many implementations for a specific role in our code base. And for def struct, we can store dynamic configurations in these structs. So for example, we can compose multiple implementations together and dynamically in runtime. So for example, our CompareAfterMover, we would receive a file mover and an empty file comparator. And this can all be changed dynamically during runtime. And it's also very explicit in our code. On the Promox side, we can define multiple mocks because each mock is just a struct and holding all the stubs and the expects. So we can define maybe 2 mocks or even more for a single role like mover. We can have a mock mover 1 and a mover 2 or even more. And what's better is we can pass these mocks to other processes because these mocks are just struct and they are just data structures can be passed around in the Beam virtual machine. We don't need to allow another process to use our mock or to have private mode or global mode or things like that. Finally, when we call a protocol function like mover.move, we are specifying role dependencies explicitly. We can just grab or search for mover.move here in our code base, and we can basically all the times we can get all the places that depend on this function or depend on the mover role in our code base. So I would highly recommend you to give role-based design a try. And when you do, please consider using protocol to implement it and also use Promox to test it. And you can find Promox on GitHub, and I'm on Twitter at dsdshcym. And you can find my blog at yiming.dev. And feel free to reach out to me if you want to discuss more on these topics. And that's basically my talk for today.